Chemicals, that very word brings fear in the minds of many people. People have this phobia for the word chemicals. All of alternative treatment systems survive because of the fear for chemicals or chemophobia. However, they fail to realize that even the medicines that they are prescribing are also made of chemicals. Well, all systems except homeopathy, of course. There is nothing in this world which is not made of chemicals. However, people attribute words like toxic, unnatural, explosive, corrosive, and dangerous with chemicals. I had done a video on chemophobia some months ago, and you can watch it from the link here once you are done with this video. However, there are some chemicals that have literally changed the history of this world. If not for these chemicals, the world we know today would have been entirely different. Today, we will look at one such chemical that brought a famous general and his army down to their knees. We will also learn about a very important chemical property too while we are telling the story. I'm sure you have all heard of Napoleon Bonaparte. Napoleon is considered one of the greatest military commanders in history. Napoleon's political and cultural legacy endures to this day, and he stands as one of the most celebrated and controversial leaders in world history. Had he not met his Waterloo, he would have gone to rule this whole planet, and we may all be speaking French instead of English. However, that was not to be due to one chemical. This is the story of a chemical that stopped Napoleon. This story may be true, or maybe it is just an urban legend. I'm not really sure, to be honest, but it certainly does teach you the importance of paying heed to science. Who would have thought that Napoleon can teach you chemistry? Hello, I'm Anand, and I welcome you to Pale Blue Thoughts, the channel that promotes scientific temper and debunks pseudoscience. Apart from being known as perhaps the greatest general in all of human history, Napoleon is known to have made many important reforms during his reign as French emperor. He introduced higher education, announced a tax code, built a system of roads and sewer systems, introduced a standard system of weights and measures, established the Bank of France, legalized divorce, closed down Jewish ghettos, ended Inquisition and feudalism, entered the Holy Roman Empire, and led to the unification of Italy and Germany. Perhaps his biggest contribution would have been the civil code called the Napoleonic Code. The development of the code was a fundamental change in the nature of the civil law legal systems. This code influenced a quarter of the world's jurisdictions, such as those in continental Europe, the Americas, and Africa. Maybe it would influence our forthcoming uniform civil code in our country too. Anyways, not many people know about these great reforms of Napoleon, but everyone remembers his battles and his final battle at Waterloo. During his reign, all countries in Europe except England and Portugal were under his regime. So in his quest to conquer the entire Europe, Napoleon attempted to capture Russia in the year 1812. Despite warnings that it would be unwise to attack Russia during the winter season, Napoleon and his army marched towards Russia. Russians, after some brief battles, retreated back past Moscow. Napoleon's army was substantial. Around 600,000 people were on his side. So Napoleon entered the city assuming its fall would end the war. But he was wrong. The army had to battle with two elements. The first element was the harshness of the Russian winter, where the temperatures dropped below -30 degrees centigrade. The French were not exposed to such clammy, bone-chilling cold, but they had their coats and trousers on. That is when they had to encounter the second element, and that element was tin. Tin or stannum is a chemical with atomic number 50. Tin is the 49th most abundant element on Earth and has, with 10 stable isotopes, the largest number of stable isotopes in the periodic table, all thanks to its special number of protons. But it also has another property, allotropy. Allotropy or allotropism is the property of some chemical elements to exist in two or more different forms in the same physical state, known as allotropes. For example, see this chemical. Yeah, that's a diamond. Now see the next chemical, that's graphite. Now see this one, it's coal. Do you notice any similarity? Their physical nature is quite dissimilar, isn't it? But if you look within, they are both the same element, carbon, just carbon. So how do they exist in different forms? That is allotropy for you. Allotropes are different structural modifications of the same element. The atoms of the element are bonded together in a different manner. I will explain this property using bricks. See the different ways in which these bricks are arranged on a wall. You can arrange it in a different manner, but the underlying matter is the same, bricks. Each arrangement has a different property with respect to their strength, appearance, and so on. This is the same with diamond and graphite. In a diamond, the carbon atoms are bonded together to form a cubic structure, but in graphite, the carbon atoms are bonded together in a hexagonal sheet-like structure. And this affects their physical properties as well. Diamond is the hardest substance and has the best thermal conductivity of any natural material, properties that are used in major industrial applications such as cutting and polishing tools. Graphite, on the other hand, is a weak conductor of heat and is a good lubricant and is also used in the making of pencils and electrodes. Coal, as you would be aware, is used primarily as a fuel. Same element, different forms, different uses. So where does allotropy come into the Napoleon story? Tin also has two allotropes. They are called alpha tin and beta tin. The beta tin's atom lined up neatly in a cubic structure, while alpha tin has a more complicated structure. Even though the differences are small, they create products that react very differently. One product is soluble in water and the other isn't. One conducts electricity and the other one doesn't. Alpha tin is a brittle, powdery, dull grey material that has little use for anything. Meanwhile, beta tin is a bright, silver, metallic material that is malleable and can be easily shaped. However, if beta tin is exposed to temperatures below 13 degrees centigrade for extended periods of time, it degrades into alpha tin and quite literally turns to dust. This is known as tin pest. The French used beta tin as it can be hammered into shape to produce neat, shiny buttons for their uniforms, and all of Napoleon's 500,000 army had their coats clasped shut and their trousers held up using tin buttons. However, they were unaware that beta tin can spontaneously transform to alpha tin in lower temperatures. Under normal circumstances, the tin buttons would have held up just fine, but when it was exposed to the extremely cold Russian winter, which reached as low as -30 to -40 degrees centigrade for long periods of time, tin pest may have damaged the metal and turned literally into dust due to the allotropic nature of this metal. As the tin buttons turned to dust, the French troops would have been unable to keep their coats sealed and their trousers up, and therefore would have been vulnerable to the brutal temperatures seen during winter. The poor soldiers were unable to close their coats and hold up their pants, and they literally froze to death. All because of the allotropic nature of tin. One by one, Napoleon's army met their deaths in the cold. Some say around 10,000 died on one single day in November, and Napoleon had to retreat from Russia without conquering them. By the time Napoleon reached back to France, his army had been reduced to a mere 10,000 soldiers. He went with more than 500,000 but returned with 10,000, all for the want of a few buttons. This chemical certainly had a hand in bringing the great emperor and his army's pants to their knees. The Russians certainly do owe their history to tin, apart from Putin and Rasputin. Of course, Napoleon's army also had been ravaged by disease, starvation, desertion, and death at the time of their retreat, so it is not like the unsuitable buttons were solely to blame. But they would have been a contributing factor, is what some historians and experts claim. Now, this would have been the greatest wardrobe malfunction in the world. Now imagine, had Napoleon conquered Russia and then proceeded to the rest of Asia, our history could have been quite different. That is because as a general, he was very capable and could have easily conquered the rest of the world. Had Napoleon known a little bit of chemistry and allotropy, I would have been delivering this video in French rather than in English. So this is the story of Napoleon and his failed attempt to conquer Russia, and also a bit of knowledge about the chemical property called allotropy. Even if this is just an urban legend, I am sure it really is an interesting way to learn something new in science. It seems odd to say that I can look at Napoleon's story and use it to help learn chemistry, but I think that one of the most important lessons that Napoleon's story can teach us people who love science is that it is important to take a look at what you think or believe to be true, and then evaluate it and be willing to make changes if necessary. Recognizing mistakes and bad ideas is essential. This is why science is all about learning, always revising ideas, trying to understand how things work, and always making changes to what doesn't work. I would like to thank Professor Kana M. Sureshan for his inputs in making this video. Professor Kana is the Dean at the Indian Institute of Science Education and Research, Trivandrum, and is a professor in chemistry and a member of the Royal Society of Chemistry, United Kingdom. We had met at Litmus 22 in October, and he certainly did a lot to revive my interest in chemistry ever since. There are more such chemicals which have changed the course of our history, and I shall be back soon with more interesting stories intermingling science and history. So I hope you liked this one. So please click the like button if you did. Please also share it for the benefit of others. If you're new to the channel, please subscribe if you like hearing scientific content, and also visit some of my older videos which I'm sure you would find appealing. I will take your leave now, and until next time, it's bye-bye from Pale Blue Thoughts.